So the other sheet I gave out about arc length. Arc length is how long this piece right here is. So the length we're talking about, how long it is. It's going to be some unit of length, like centimeters, inches, meters, something like that. All right. And the two things that influence arc length, how long this is, S specifically, are the radius of the circle involved and the angle measure, central angle measure of the circle involved. Those two things account for how we find arc length. And R is going to be given in some unit, like it'll be, the circle has a radius of 5 miles, the circle has a radius of 10 inches, whatever. All right, it'll be something like that. The degree measure, or the angle measure, is going to be either in degrees or radians, and that's going to establish what formula you use. All right. If it's in degrees, we got the d over 360 times 2 pi r. If it's in radians, we just get dr. So we want it to be in radians because that's easier. The reason it's such an easy formula in radians is we know that there's 360 degrees in a circle, right? There's also 2 pi radians in a circle. So if it's in radian measure and we take d over the entire circle times the formula for circumference, the 2 pi's cancel. That's why it's such a nice, friendly little formula. But so again, if it happens to be in radians, you just multiply those two and you get the arc length. If it's in degrees, this over 360 times the circumference of the whole circle. Right, so, example 9. Find the length of an arc that subtends a central angle of 120 degrees in a circle of radius 10 centimeters. So this subtends, I don't know, it's just a word they like to use. Anytime they ask for a length of an arc, subtends means that it takes up the entire length of the circle part that is 120 degrees. All right. So when they say find the length of the arc, how long is that thing? And again, you have to ask yourself a simple question on these arc length problems. How did I get the angle measure? Is it in degrees or radians? If it's in degrees, I can see degrees there. I'm going to use the degree formula. D over 360 times 2 pi r. I simply put the angle measure there, and I put the radius there, and I work it out. So if I do this, I'm going to get 120 over 360 times 2 pi times 10. I'm fine with decimal approximations on these problems. Arc length decimal approximations are fine. For me personally, I'm simply going to type that exactly in my calculator. And when I type in all this stuff, I type this times this times this times this divided by that. I do the divided by the last. So 120 times 2 times pi times 10 divided by 360 equals 20.94. Unit of length will be whatever the unit of length on the radius is, in this case centimeters. All right. Notice that I did use the pi button. Make sure you're using the pi button. Don't approximate 3.14. Use the pi button. It gets better approximation. And whatever you get for the answer, just go a couple decimal places. It's fine with me.